Okay, now let's talk about probability distributions. A probability distribution is a list of all possible values of a random variable and the probability that each will occur. So we have two ways to represent this. A probability density function, or a PDF, and for a continuous random variable it's written PDF equals f of x, or small f of x, equals, which could also be written p, or the probability of x. And x is indexed with I for every possible value of x, every possible outcome. The area under the PDF between 2 points is the probability that the random variable falls between those 2 points. We will see an example of this in a moment. Properties of a PDF. All probabilities are non-negative, meaning that the probability that you have any value, xi, or any possible outcome, it has to be positive. Probabilities of a set of all possible outcomes sum to 1. So the sum of f of xi for all possible outcomes has to be equal to 1. I just realized that in the previous one I wrote less than or equal to 0. It should be greater than or equal to 0. The CDF, the other way to write this, is the cumulative density function. The CDF is written with a capital F of x, which is equal to the probability that large x, or the random variable x, is less than or equal to small x, or the outcome, which is equal to the sum of this symbol that looks like a strange looking E is the sum symbol of xi for all xi less than or equal to x, the probability that each of those xi occurs, the events occur. The probability that a continuous random variable is less than or equal to a certain value, that's the definition of the CDF. Now the example, the probability that a commute time will be less than 20 minutes is 0.78. We would write that as capital F of x equals the probability that the outcome x, or the random variable x, is less than or equal to the outcome xi, which would be the probability that the random variable x is less than or equal to 20. So this is drawing if we go to work and we find, or school, and we find that our commute time is less than 20, that's the outcome, that's the random variable. What's the probability this occurs? 78%. So let's see what this looks like in graph form. So we have a PDF and a CDF, and these are written in your book as well. The top is the PDF, and then the bottom is the CDF, and these relate to each other. So the PDF is, let's take x1 and x2. These are two possible outcomes of the random variable x. x1, if you follow the line from x1 up to the blue bell curve on the PDF, that gives you the probability that the random variable x takes on the value x1. Note that for a continuous variable, that probability is equal to 0, or it trends towards 0. So the PDF for a continuous variable really is only useful for telling us the probability that a random variable falls between two values, say x1 and x2, and that would be the green area highlighted in that PDF. Also written as p of x1 less than or equal to the random variable x less than or equal to x2. And you can see how this relates to the CDF below. The CDF gives you the probability, so if we find the value x1 on the CDF, and we find out what its associated probability is, the capital F of x1, that gives us the probability that the random variable x is less than or equal to x1. So f of x1 is all of the area in the PDF less than or equal to x1. So let me try to draw that in there for you, what I'm talking about. I'll do that in, how about rainbow. So what we're talking about here is the CDF for x1 of f of x1 here is the probability that x1 is less than or equal to the probability the random variable x is less than or equal to x1. So it's that area I just highlighted in sort of rainbow color. That's what this value is giving us. And the f of x2, the capital F of x2, the CDF of x2, is the probability that the random variable x is less than or equal to x2. And so the difference between those two values is also the PDF, the green area, the probability that the random variable falls between x1 and x2. Note that the CDF asymptotes at 1. This line here is equal to 1. So that was the CDF and PDF for a continuous random variable. Now let's look at an example of a discrete random variable, like a roll of a die. Maybe we'll label this random variable M. The probability of any outcome is P of M. Outcomes are written as lowercase m equals 1, lowercase m equals 2, and so forth. The probabilities are equal to P1 equals 1/6, P2 equals 1/6, etc. So this is a fair die. So the PDF of the capital M is in the graph here. So for every possible outcome, 1 through 6, the probability of attaining that outcome is 1/6. So it's just a histogram or a bar chart of 1/6 for all 6 outcomes. The CDF is the probability that we get something less than or equal to any of these outcomes. So for example, we might take the probability that the roll of the die is less than 4, right? So if it's less than or equal to 4, sorry, this value here, we can draw that over there, should be 4/6, because there's 4 possible outcomes less than or equal to 4, 1, 2, 3, 4. Each of those is associated with a probability of 1/6. We know that from the PDF above. Summing that up, we get 4/6. And then again, we asymptote at 1. So the probability that the roll of a die is less than or equal to 6 is 100%. Now let's look at a special case called a Bernoulli random variable. A Bernoulli random variable is a random variable that takes on only 2 possible values, usually defined as 0 or 1. An example might be heads versus tails. We might define heads as equal to 0 and tails is equal to 1. So let's define F to be the outcome of a coin flip. So capital F is equal to 1 with probability P, and 0 with probability 1 minus P. Why 1 minus P? Well, we know that our outcomes have to sum, the probabilities of the outcomes have to sum to 1, and so if we define, if the probability of the outcome 1, maybe tails, is equal to P, then the probability of the other outcome has to be 1 minus that. So let's suppose P is equal to 1 or 0.4, and let's draw the PDF and CDF. And that's what we have over here. So the PDF of a Bernoulli random variable with P equals 0.4 will have the outcome 1 has probability 0.4, and the outcome 0 has probability 0.6. And then the CDF is going to be the outcome 0. Anything less than or equal to 0 is equal to 0.6, and then anything less than or equal to 1 is equal to 1.